Hello, geometry! Welcome to Snow Day 2/24/22. Alright, so here's the first part of the notes that we're going to have for today. I'm going to get out of the way and then you can pause the video and write these notes down that's up here so far. Okay, so you should have all those written down, but now I'm going to explain some things to you, okay? So first off, this is the last section of chapter 11. We're talking about lateral area and surface area. And the main idea is that the lateral area is the area of every surface except for the base or bases added together. Here's an example. This is a triangular prism. Notice that I talk about prisms here. It's got two bases. Triangular base, triangular base. Now what I didn't write up here is you're going to need to add to your notes right now. Write this on there. The base is the shape that goes all the way through it. So, for example, see, look, triangular base. It's a triangular prism. You might think, well, isn't the square or the rectangle the base if I do it like this? No. Notice this rectangle gets smaller and smaller and smaller. The thing that's actually stacked on top of itself is a triangle. You take that triangle, the exact same triangle, and stack it on top or stack it to the side, and it becomes a triangular prism. In fact, triangular prism, the base is the triangle automatically. You need to memorize that. For instance, this is a hexagonal prism. Two hexagon bases. But notice what the other sides are. Rectangle, 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 rectangle. Let's see. Triangular prism. Triangle bases. Do you know how to find the area of a triangle? I think so. Yes, you do. Okay, so triangular bases. But notice what's on the sides now. Rectangle, rectangle, rectangle. Wow. Look at this one. What type of shape is this? What's the base? It's a triangular prism. And notice, two triangles for bases. And this time, three rectangles. Three sides on a triangle, three rectangles. Six sides on the base. It's a hexagon. How many rectangles? 1, 2, 3, 4, 5. Well, what do you know? 6 rectangle faces. This is called the lateral area. So surface area is the area of every surface added together. So if I want to find the surface area of this hexagonal prism, then you would find the area of a hexagon. Yes, you have to know how to find the area of a hexagon using what we just now did in the last sections. And you got two of them, so it's 2 times that area of the hexagon, plus the area of every rectangle. Now think about this for a moment. I know the perimeter of this base. To find the area of these rectangles, I go length times width, plus 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 length times width. 6 times. Or you could find the perimeter of the base times the height. That right there, the perimeter of the base times the height, would be the lateral area for any prism. That's the shortcut, by the way. That's the shortcut. Okay? For any prism, the lateral area is just the perimeter of the base, big P, perimeter of the base, times the height. Now think about that for a moment. See, it's just the perimeter of the base times the height. If I had it on its side, it would be the perimeter of the hexagon times the other direction, the height of the rectangle. That's the way you'd find the lateral area. Now, if you don't want to remember the shortcut, it's perfectly okay. Okay? Make sure you understand that. You can just find the area of the two hexagons if you're finding surface area. Otherwise, lateral area, you don't find the area of the two hexagons. And you just go length times width plus 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 length times width. It's totally up to you. I just want to make sure you get it correct. Okay? Got it? Good. Notice this one. Let's make sure you got it. What is this? Ooh, you know what? This is a rectangular prism. It's got a rectangle base. And the neat thing is, if I turn it this way, then this one is a base. Because, see, it's all rectangles. You see that? It's all rectangles. So whatever I put it on the bottom, these are the bases. Because it's a rectangular prism. So if I said find the lateral area of this rectangular prism, I go length times width plus length times width plus length times width plus length times width. Or length times the height plus the length times the height plus the length times the height plus the length times the height. You find the area of all the surfaces but not the bases. That's lateral area. So surface area, guess what surface area is? Find the area of all the surfaces. You know how to find the area of rectangles, so find the area of all the surfaces. Now that was dealing with prisms. A shape that has a base, and it goes all the way through the object to the other base. Two bases is a prism. Okay? Two bases. And the shortcut for finding the lateral area was just find the perimeter of the base times that other dimension. And that'll give you the lateral area because you don't want the bases. Surface area, you just add the bases to it. Okay? The key thing here is going to be very easy for you to make careless mistakes. I know, careless mistakes. Now let's go to pyramids, shall we? Y'all have seen a pyramid like this. This is a square-based pyramid. So on a pyramid, but notice, the shape that goes all the way through it, the base is the square in this case. It could be a rectangle, it could be a triangle. See, here's a triangular based pyramid. It's got an equilateral triangle as a base. And then it goes up with three. They're equal right here because this is an equilateral triangle. Make sure you understand that. That's a regular triangular based pyramid. Alright. Let's go back to the square based pyramid. Now if I want to find the surface area of this, surface area, I find the area of that base, length times width. But now I need to find the area of the triangles right here on the lateral faces. They may give you the height and the width of the square. Well, then you have to find this right here, which is called the lateral height. I'll draw a picture for you. Let's draw a square, draw a dot right up here, and then I just connect them. And see right there? You've got to find that lateral edge. So what you're wanting to find is the area of this. Now the neat thing is, notice, you've already got this direction. So let's say this is 8 centimeters. Right across here. You want to be able to find this, and then you can find the lateral, okay? The area of this, plus the area of this, plus the area of this, plus the area of this. Right? It's just, and it's 4 of them. They're equal. Or you could say the perimeter of the base. But since it's triangles, what's the area of a triangle? Anybody remember what the area of the triangle is? 1/2 base times height, right? The area of this is 1/2 base times the height. Okay, 1/2 the base of the triangle times the height of the triangle, which is the slant height. Okay, you got to keep that in your mind. Now, y'all have done surface areas before. You have. I know you have. So this is basically a review. Hopefully you'll remember it. I'm going to give you 17 problems, not 20. 20 problems will be on the homework. 3 are from something we already did in the previous section, finding segments of circles. But 17 of them are finding the surface area and the lateral area of different types of shapes. And so on pyramids, you have a square base pyramid. You have a regular triangular base pyramid. And for the most part, that's all the different kinds of pyramids we have. But you can have a hexagonal pyramid. Take a hexagon and go up to a point and shave off all this stuff, and you'd have a hexagonal base pyramid. I just don't have that shape to show you. Okay? So on pyramids, you only have one base that you would add to it to get the surface area. Okay? But you have to find the area of the other sides. Now notice, I went ahead and gave you the formula for the cylinder with 2 bases. Notice the cylinder has 2 bases, and the bases are the circles. But how in the world do I get the lateral area of a cylinder? Well, you know how to do it. See this sheet of paper right here? I can make it into a cylinder. A magician. Look, watch. Wait for it. Look at that. It's a cylinder now. See, here's a base circle. Base circle. It's a cylinder. But now, if I just want the lateral area, woo, what is it? Base times the height. Base times the height. That's all it is. But what's this base right here? What is it? Wow, it's the circle, but it's the circumference of the circle. Now, what's the circumference of the circle? Wx, y, and z around the circle is pi times d. Or Wx, don't go far, around the circle is 2 pi r. Notice the lateral area is 2 pi r times the height of that cylinder. 2 pi r times the height. Just like that. Now the surface area takes that 2 pi r times the height. Okay? 2 pi r, circumference, times the height. And then adds 2 pi r squared. Notice, when the area is declared, fill in the circle with pi r squared. Just like that. Okay? Videos on my YouTube channel. Alright, so, circle, circle. Add them together and you have the surface area when you add the 2 pi r times the height plus the 2 circle areas, 2 pi r squared. That would give you the surface area of a cylinder. Now a cone has a circular base, but it goes to a point. And this is a formula for the lateral. Now you know how to find the area of the base. Pi r squared, right? So surface area is pi r squared plus this stuff. This stuff right here, this lateral area right here, is pi r times the lateral, or the slant height, L. When you see slant height, like on this square-based pyramid while ago, this is actually called the L, the slant height. So the slant height on this cone is L. That's called the slant height. Slant height. Just like that. Okay? So make sure you understand the lateral area of a cone is just pi times the radius of that circle, times the slant height. If they don't give you one of these, then you have to find it using Pythagorean theorem, special right triangles, sine, cosine, and tangent. Oh, gasp, I know. You have to know all that too. Don't forget it. Okay? So that's how you find the lateral area of a cone. So the surface area of a cone, you just add the pi r squared to it. See? Cones, lateral area is pi r L, surface area pi r squared plus pi r L. Now, believe it or not, that's almost everything you need for this section. But just to make sure we're in good measure, I'm going to bring out a can of peach slices. Okay? You'll be asked to find the label, you'll be asked to find the area of the label of a can of something. Or a Coke can, or something like that. Notice what this is. What shape is this? Dare I say it? What is it? Yes, you are correct. It's a cylinder. So, in the cylinder, if we just want the area of the label, what's that called? Lateral area. Right there. 2 pi r times the height is the lateral area, and that's what you do to find the area of the label of a cylinder of some sort. 2 more formulas, and I'm going to have to erase this, so it'll be magic that this disappears. Welcome back. Surface area of a sphere. Okay? It's a ball. Okay? It's a ball. That's all it is. It's a ball. So you take the ball. Surface area of this ball is equal to 4 pi r squared. Yes, it's the equivalent to 4 circles, pi r squared. Right? When the area is declared, fill in the circle with pi r squared. I can't do it without beatboxing at the end. Alright, so the surface area of any ball is just 4 times pi times the radius. So I'm going to draw a ball for you. I'm going to draw a circle, I draw a center. This is the way you draw a sphere, by the way. Then you draw a kind of arc in front of it, and then you draw a dashed arc in the back. Voila! A sphere. So this radius right there, or this radius right here, or this radius right here. See, they're all the same, right? That radius goes all the way around that sphere. That means I can use that radius anywhere I want. So that's something good to know. So that radius is this radius right here, and you just plug it in, and that'll find you the surface area of a sphere. But what if I said I wanted to find the surface area of a hemisphere? Surface area of the hemisphere, including this part right here that's closed it off. Well, it'd be half of the 4 pi r squared, right? Plus the pi r squared, because you want to add the area of the circle right here. You will have to think through the problems. I will give you a solution guide for the worksheet, but you must think through the problems. This section right here you will need to know for chapter 12 as well, especially the parts about the bases and about the different things going on, like the base here, the triangle, and how to find the area of those triangles. You've got to be able to do that. So make sure you email me or Mr. Shell if you have any questions over the homework. Make sure you do the homework really well. You should be able to do it based on the knowledge you have right now. I know I didn't give you any examples, but that's what we'll give you on the homework for. There are going to be 20 problems of the homework. 3 of them will be previous knowledge. 17 of them will be using surface area and lateral area. Have a great day and drive safely if you're driving anywhere or getting out and going sledding or anything like that. And I will see you soon.